Ok, bon, il y a une récotation toujours, just in case. Allez, right. So, download, so open the first one. Hello, first one, I mean, the test for comparing means dataset one, the Excel one. Okay, test for comparing means dataset one. So let me share my screen here. Mais c'est déjà fait en même temps, that's the whole point of doing a tutorial. So open the dataset. Let me know if it's working fine for you. Okay, so normally that's what you will see. So can you see my screen here? You see the Excel sheet?
Oui, monsieur.
Good. Allez, right. Bon, that's a simple data set, and we're just going to run the different tests for comparing means. We'll do that first on Excel. So hopefully, let's say in 30 minutes around, everyone has been able to install SPSS so that we can do the same thing using SPSS. So first, let's do a one sample t-test. So I think we did that already, but not know if we did it on Excel actually. So what I'll do, I'll just work on one example together with you, and then you try one by yourself. So that's the idea. Okay, so first thing, let's look at the small data set we have here. So we have 4 variables. Let's understand the data set. So we have variable 1, which is height. And you see 15 here, basically. Oui? Someone says something? So it's variable 1, height, 15 years old. Our variable 2 is again height, as you can see, and that's height for 21 years old. So suppose we have a sample. Okay, let me just write this first. So variable 3, and our data set is IQ score, as you can see, and then we have variable 4, which is gender. Okay, so très simple. We have a small data set with 4 variables only. So what we should note as well here, so we have our sample, okay, of size n, it's 70. Okay, so you exclude that. So we have n is equal to 70. Now let's define that. So let's just say it is 70 students. Okay, so we have a sample of 70 students. Let's make it relatable. Okay, suppose you have collected data from 70 students. So you have a sample of 70 students, and that's the variables we have in our data set. So we have data about height. So that was, let us say, the height of the students when they were 15 years old, the same students, right? So if you want, we can make it just for that to be clear. So that's, let's say that's student 1, that's student 2. Okay, I mean, I'm just doing that just to make sure that everything is working in your mind, because for some of you that will be easy if you still have your statistics knowledge still fresh in your mind, but if you've read something which is like, which seems to be a distant past, then you will need to do some more effort. Okay, so that's our cases, all right? So let us say that's the cases, actual cases, observations. Okay, you can call it cases, observations, however you want to call it. Good. So we have a sample of 70 students, okay? And the point I was just, because that needs to be very clear. So the same student, we have their actual height in centimeters when they were 15 years old, and then when they actually are 20 years old. So let's just say they are currently 20 years old, everyone. So we actually have data about what was their height when they were actually 15 years old as well. Okay, so let that be very clear. And then we have data about IQ, gender. Okay, so about student 1, student 2, etc. Okay, now those are numeric data. Okay, scale level as we'll refer to it. Okay, this one IQ of course is interval, height is ratio, and I mean in terms of level of measurement, if you recall, most importantly both are numeric, right? So we don't have to. There's nothing really to do like in addition. The numbers speak for themselves. They are already representing the actual quantity, the actual amount, if you want, sized. For example, here you have a height, so actual height. Okay, so the number represent the height. The IQ score here represent intelligence. It's a measure of intelligence. For gender, it's categorical. It's categorical, more specifically nominal. So here we have the values, but you should know what the values represent, obviously. So let us just make a note here. I'm taking time to do that because actually I want to show you that that's something you need to take care of always. Okay, so be very clear about what data you have. Here we have a very small data set in terms of number of variables. But normally when you be working on your research, when any research work is for your dissertation or any other research, you might be having like 50 variables. Okay? But the same principle applies. Be very clear about your variables. So know how they have been defined, etc. very well before you start with analysis or whatever. Okay, so we have male coded as 0 and we have female coded as 1. So that's how it is. Okay. Now we're ready to proceed with our analysis. Okay. So let us first look at the one sample t-test. Okay. So what's one sample t-test? And what I will do here, I'll just copy that. You don't have to do that. Actually, you could actually just do the test and then have the results on another sheet. But just to, like, for the sake of explanation, okay, let's copy the whole data set. Let's put it here, and then let's see what we're going to do. Okay. Now, suppose we have a research question like that. Now, I want you to do that at the same time. Huh? So if I'm going too fast, you stop me, and then you take time to do it. Okay, so don't hesitate to stop me if I'm going too fast. Okay, so let's say we have a research question here, and let's take a simple one. So let us take, for example, IQ. Okay, and let us say here that so is the average IQ of students different to the world average of 100. Okay. This relate to score here. Okay. Yeah, I don't necessarily have to. Yeah, good. So, so no question mark here. So what's our research question? All right, is that clear? So you will remember that, I hope. Okay, the one sample t-test, we use it when you want to compare your estimated mean value. We're comparing means here. Your estimated mean value for variable x, whichever variable it is, with a reasonable assumption that you have. That's very important. Okay, so whatever the reasonable assumption is, so that would be the expected mean value. And of course, as we said, the reasonable assumption, there should be a logic behind. For example, as we know, IQ score normally is on average 100. So if you want to compare whichever sample you have, population rather that you have, okay, you'll want to do that against like something which is reasonable to expect. So for example, the average of 100. So when you think about it, so if like, let's just say in the context of students, if it goes as per the norm, okay, you would expect it to be 100. But let's say you have reason to believe that it is different. Maybe it is more, maybe it is less. Okay. When we look at inferential statistics, you don't necessarily have to specify whether more or less. You might be having theoretically a reason to think whether it's more or less. Okay. Then we go for a one-tailed test instead. But as a general principle, it's okay to always go for a two-tailed test instead, even if you have kind of reason to believe it's more or less. Okay. So we'll stick to two-tailed tests. Okay, so we have a lot of simulation studies which have been done and actually which show that it's actually better to do a two-tailed test. Okay, because you have lower actually type 2 error when doing a two-tailed test. Okay, so we won't go into that detail, but so let's just stick to a two-tailed test. So that's a research question. Now, what I want you to do for me, write the hypothesis, okay, and then we proceed. Okay, so I ask you to do that, and then you just send it in the chat box, okay? So H0 and H1, what's going to be? I think we already took an example like that last time, so that should be easy for you. Okay, so what will be your hypothesis? H0, H1. Okay, let's go very quick because that's something we already did actually, so it's more revision this one. So tell me what would be H node and what would be H. Now, the best thing for you to do is actually to write it on Excel as well. Okay, so do it at the same time. So write it. Of course, if when you need to correct, you can correct it if it's not good, but try to do that. Okay, you can actually make it a subscript and make it nice looking. Okay, so that's what I'm trying to do. So normally that's H1 and H. Oops. No. Subscripts. Okay, so tell me what H node will be. And one H1, I don't know what H1 will be. I'm just remove formatting, c'est pas important, mais bon, if you want to do already. Okay, anyway, okay, when you're ready, just send it in the chat box and I'll see what you've written. What to be H1, what to be H node. Yep, still waiting for your answers. Yeah, so there's no difference over IQ of young students and the average. Which one there is a difference? Yep, exactly. Okay, so oops. Okay, so that's good. Zaire, thank you. Okay, we'll just copy that. So I hope others have got it right too. Okay. Now, I told you, I think, in the tutorial session, so don't hesitate to share. Okay, so whatever you've written or whatever. So because the goal here is to learn, so don't worry if you go wrong. Okay. So, okay, we got our hypothesis. So basically that's what we're saying. Okay, so you can write it in like notation form as well, as you know. So H note will be that mu is equal to mu naught, right? So mu, the average IQ of students, is equal to mu naught, that is 100. And here mu is not equal to mu naught. Okay. Now, of course, we don't have data about so for all students, so we can't answer this directly. That's why we make use of an inferential statistical test, in this case, a one sample t-test. And based on our sample of 70 students, we'll see whether we have enough evidence to do what? Enough evidence to reject the null hypothesis. I hope you're getting used to this language now. Okay, so we do an inferential statistical test, and then we see, we look at the result, and we will try to draw a conclusion. And basically, the sense of it will be to see whether we have enough evidence to reject the null hypothesis. In which case, we are happy as a researcher normally, because if we are able to reject the null hypothesis, it means that we have support for our claim for our alternate hypothesis, which is actually our research hypothesis, right? If you remember, again, just like the criminal case, the police doing an investigation and then trying to find evidence. So you can imagine the police so trying to actually find evidence to support a claim around that someone is actually guilty. So the whole process, the whole reasoning here is to see, do we have enough evidence to reject the assumption of not guilty? So same thing here, okay? So hopefully that's getting kind of clear in your mind, and you're not finding that difficult. Okay, now let's do the test. Okay, bon, by the way, the one sample t-test on Excel is a little bit tricky. It's actually easier to do it on SPSS, much easier to do it on SPSS. But well, it's not difficult, but it's just that there are a few steps which kind of are like not straightforward. And so there are basically two ways to do that. Okay, we can look at both ways. So the first way is to actually make use of the data analysis function here. Now, what I will ask you is that go on your Excel sheet and then go on data and tell me whether you have data analysis here, because if you've not, for some of you, this might not appear. So then you just need to let me know. So please do that. Go on your, check that, go on data on top here, your data tab, and then see whether you have data analysis appearing. If you don't have data analysis, then you need to there's something you need to do basically, but you just let me know. I mean, if it's there, then there's nothing else to do.
Non, monsieur. Et non.
Yep.
Monsieur?
Yep.
Et non.
So you don't have it.
Non.
Okay. So okay, for those who don't have it, so what you need to do, you go on File, okay, Options. Okay, just do that. So File, Options. All right. And then you click on Add-ins. Okay, so just do it at the same time. Okay, so I say again, File, Options, and then you click on Add-ins. And then you will see here, Manage Excel Add-ins. So you click on Go. Okay, we're good. Yep. Click on Go. So you click on Go, you get this appearing, this small box here. And now you need to click on Analysis Toolpack. Okay, so normally that would be unchecked. So you check it, Analysis Toolpack, and then you say, okay. C'est bon?
Oui, monsieur, c'est bon.
Yep. Okay, so once you've done that, then normally you will have this option here. But let me know if you do have it, because if you...
Oui, monsieur, maintenant c'est bon.
Okay, great. Okay, allez, right, bien bon. Okay, so let's do that now. Okay, so what you will do, so we just have one additional step, because well, let me just show you what it is about. So if you click on data analysis first, you will see you have so click on data analysis, right, and you will see you have a number of options here. So basically that's an add-in, okay, what you have in Excel, and it gives you the option here to perform a number of tests, actually, which you can do on SPSS, obviously, but you can as well do it on Excel. So you have a number of tests. It's limited compared to SPSS, but still you have quite a wide range here of tests. Actually, you have most of the essential ones, right? So you see ANOVA, single factor, ANOVA two-factor, etc., correlation, regression, and you see the t-tests here, okay, which are here. And this is what we're concerned with, right? Okay, now what you will notice here is that we have t-test, and we have t-test for two samples. That's our independent samples t-test, what we normally refer to as independent samples t-test. If you remember very well, last week when we looked at the independent samples t-test, I hope you remember, we said that when you look at you actually have to, when you interpret the results, sorry, you first need to consider the test for homogeneity of variance first. Okay, when SPSS gives you the output, you have a test for homogeneity of variance. You need to consider that first, and then you look at the main output. Okay, so you can see here it says t-test two sample assuming equal variances, t-test two sample assuming unequal variances. Basically here you need to tell Excel. Okay, according to SPSS, it gives you the output and then both possibilities. This one is for paired t-test. Okay, now we're going to look at all those tests. Okay, the independent samples t-test, the paired samples t-test, which we are going to do next. But right now we're looking at the one sample t-test, which is where you compare an estimated mean with a reasonable assumption. And what you see here is that it doesn't actually give you any option here. If you remember in SPSS, let me just launch SPSS, because we've done it just once last week. I don't know if this is still fresh in your mind. Okay, so if you go on your SPSS, you see analyze here, compare means, and here you have the test. Okay, one sample t-test. So you have actually the test. Okay, one sample t-test, and then you have an independent samples t-test, and you have a paired samples t-test, and then you have a one-way ANOVA. Okay. Now in Excel, in the data analysis toolpack, okay, what we just added, okay, we find those options. Okay, for the independent samples t-test, it's called two samples there. Then we have a paired samples t-test and the one-way ANOVA as well. It's there. There's no option for one t-test. I will just show you again. Okay, let's go back to our Excel sheet. And what you can see here, you see the t-test paired, that's a paired sample t-test. And then those two relate to the independent samples t-test. Let me say that again. So you see independent samples t-test, that's what you have here, the two samples, both, okay? And then you have the paired samples t-test. Okay. Why do you have two for independent samples t-test here? Because in SPSS, you have only one. Okay, because when we do the independent samples t-test, we have to test for an assumption, that is the test for homogeneity of variance. In SPSS, you just do the test, and then in the output, you have both options. It actually runs both actually for you, and then you decide based on the result of a Levin's test. Okay, this is the assumption, the test for the assumption, homogeneity of variance, equality of variances. So based on that, you decide which one you're going to interpret. In Excel, for the independent samples t-test, you need to choose, okay, which one you'll do. either or. Okay, so those two are for the independent samples t-test. Okay, so that's where you find it here. And then the pair sample t-test, so that's the same here. Okay, so that's it here. Okay, we're clear about it. For the one-way ANOVA, we're just going to look at it afterwards. Okay, but I'm just kind of showing you the broad picture here, and then we look at the specific test. That's where you'll find it. So ANOVA is called single factor. Okay, in SPSS, we're referring to it as one-way ANOVA. Okay, and here reference is made to single factor. Basically, it means the same thing. We're looking at only one grouping variable, one categorical variable. It's referring to this as single factor here, where we say one-way ANOVA because we're looking at one factor, one categorical variable. Okay, so basically two terminologies to mean the same thing. So yeah, so to recap, we have those tests here, what you see there in SPSS, comparing means, one-way ANOVA, that's where you find it on Excel. Paired sample t-test is here, and those two are for the independent sample t-test. In Excel, you have the option one sample t-test. Here you don't have it. Okay, so I hope we're clear about it now. So what do we do now? If we want to do a one sample t-test in Excel, we just need to use a small trick, and we just need to do to compute, not compute, but just insert a dummy variable with just two observations. Okay, and you see why we're doing that. It's just a way around. Okay, so to do a one sample t-test, because we don't have the option for some reason. Maybe we will add it afterwards. I don't know why we didn't add it. So there are two ways actually to do it. We just use this first now, the first way. So just create the dummy variable. Okay, so just do that, create the dummy variable. So just name it dummy, and then type in 0, 0, observation 0, 0. C'est bon? Yep. Okay, now we go on data analysis. And now we're going to select t-test to sample assuming unequal variances. It's as if we're doing an independent samples t-test. Okay, so just select that. So we're just kind of tricking Excel to do a one sample t-test for us. That's what we're doing here. Okay, good. So we select that t-test to sample assuming unequal variances. Ideally, try to do it at the same time when I'm doing it. Okay, so click on that, and when you click on OK, or you can double click as you wish. Okay, now it tells us input. So we're going to select now our variable. So what are we really aiming to do? We want to do one sample t-test basically. So we're just firstly going to select the variable range. So we're looking at the variable IQ, isn't it? So we select IQ here, the whole data set. So that's what we do here. You select the whole range here. Okay. Have you been able to do that? Don't hesitate to stop me whenever you need. I mean, again, that's the whole point of doing the tutorial. So, because if you attend it just like a lecture, then
C'est bon.
C'est bon? Good. Yeah. Okay. Anyway, now for the second range, what we will simply do, we're going to just select those two observations here that we have as a dummy variable, which is basically a blank variable. Okay. Remember, we're just tricking SPSS here to do Excel, c'est-à-dire to do a one sample t-test for us. Okay, so we just have a dummy 0, 0 here. Just select it. Okay. Once you've done that, then you go on hypothesize mean difference, and the hypothesize mean difference will actually be your reasonable assumption that you have, because in any case we've inserted 0 here. So what we expect to see is actually 100. Maybe you recall on SPSS where we actually insert the test value here. Basically, we did the same thing here, but we just had to include a dummy variable here because we don't have the option of one sample t-test. But at the end of the day, with the way the formula is basically, and the way things are computed is going to be the same thing. So hypothesize mean difference is 100. Why 100? Because that's actually what we expect. Okay, that's a reasonable assumption. So we do that. Alpha, that's our significance level. Hope you remember that. By default, just like what it is on SPSS, it's going to be 5%, 0.05. And as we said, we're going to stick to 5%. If ever you have reason to change it, then you're going to change it. But otherwise, we'll always kind of assume that we go for the 5%, 0.05. Okay, so you do that. And then you click on output range here. Now you can select where you want your output to be when Excel will give you your output table. If you select new worksheet here, it's going to create another worksheet for you, and then the output will appear there. But if you want the results, the output of the t-test to appear here itself, then you can just click on output range, and maybe we will do that just to have everything here instead of having to open another sheet. So then you just click on this, okay, click on that, click on the cell you want. So here's going to give us the results here. That's what it is here, output options. Okay, so far so good. So when you click on OK, and what's happening here? Input range. So maybe there's a mistake somewhere. Let's do that again. So our IQ scores here for some reason. Yep. Okay. And here we are. Okay.
Monsieur, comment vous expliquer le output range?
Oui, bien sûr. Okay, so let me delete that. Okay, let's do that again. Okay, so let me do that again. So you go on data analysis. I think that's good. You go on to sample, assume unequal variances. Why we're saying unequal variances? Because in any case, we're using a dummy variable here. All right, so the dummy variable will have zero variance basically. So you don't want to say equal variances. In any case, as I say again, we're just tricking SPSS here. Okay, so for the output range, pour ça c'est OK, hein, variable 1, you select your variable 2, you select the two values for dummy variable. Okay, that's what it is here.
Oui.
And here, that's your reasonable assumption, c'est 0.05. Output range, tout simplement, if you want the output to be on another sheet, you want Excel to create a sheet automatically for you, then you click on new worksheet. Okay, and Excel is going to create a new sheet automatically and then insert the output of a t-test. Par contre, if we want the output to appear here itself, when you go on output range, okay, you go here, or you click this here, and you select an output range. I mean, a particular cell where you want the output to be. And let's say we want this here, so when we click on that, and when we click on OK, I think yeah, okay, so I mean, as soon as if you click something else, is going to mess it up, then you just need to make sure that you have the right thing selected. Okay, so then you click on OK, and then you get your output. C'est bon? Have you been able to do it?
Oui, oui, c'est bon.
Okay,
Merci,
bon,
monsieur.
monsieur.
Okay, good. Okay, so now we have a result of a t-test. So we don't bother about this here because, again, as I said, that's just a way to kind of go around, okay, and do a one sample t-test because we don't have the option here. Okay, so that's the result that we have. Okay, so that's IQ, and we have our result. Okay, so there's another way to do it. We can actually do it like stepwise and use a formula, etc. But I think I will bother you too much with it. What we can do now is interpret the result. But before that, let me do the test in SPSS as well. Okay, I want to do it concurrently. I don't know if you've been able to install SPSS par contre. Have you been able to do it entre temps? No.
Oui, monsieur.
Okay, great. So for those who have been able to do, hopefully all of you, just open the same data set on SPSS. So you will see actually when you have downloaded, I think I did upload both on Google Classroom. Yeah, so you have a SPSS version as well. Okay, so you have a SPSS version, test for comparing means. So just open the SPSS version and you should be working fine. Okay, I'll give you 2 minutes to do that. Just let me know once it's working and you've been able to open the dataset in SPSS. Yep, c'est bon. Hmm.
Oui, c'est bon.
Okay. What about the others? Let me hear from you.
Monsieur, un instant, il est download là.
Okay. Okay. Yeah, but let me just have an idea. So how many of you have been able to do it already and how many not yet? So maybe all of you who have been able to do it, so just kind of raise your hands, use the icon, you know. Appreciate. Hmm. I mean, no one is raising their hand. You know how to use a raise hand option on Zoom, no? Anyway. Okay, drink testing, still 40 minutes left. Okay, so it's taking time. Well, okay, so I won't bother you too much with it. I think it might be taking time. So what I will do, okay, well, at least you will have a hands-on experience on Excel. I will do it on SPSS as well, so please follow it. Okay, so look at the steps. And then, so as soon as you've been able to install, okay, so I count on you. Si c'est à 3 heures, c'est à 4 heures, 5 heures. I mean, do it today. That's the point. Even if it's at night, if you've been able, as soon as you've been able to install SPSS and open the dataset, just make sure you just run the test. Okay, because we'll do everything. We're going to look at the, running the test and doing the, and look at and interpreting the results, etc. So that's something we'll complete. What will be just missing then, for those of you who have not been able to install SPSS, is the actual practice of just running the test on SPSS. So I count on you to do it then afterwards. C'est bon? C'est bon? On peut continuer comme ça? Yep. Okay, good. Okay, so one sample t-test on SPSS. So using the same data set, so we should get the same result. What we got on Excel. So we're going to analyze this time, compare means, one sample t-test. And so our test variable, of course, is IQ. And our test value is 100. That's our reasonable assumption, right? What we're comparing our estimated mean with. Okay, you can just click on options and just check. So 95%. I hope that's also clear in your mind. You see on Excel there it was returned. C'était écrit quoi? When we actually run the test. Let me show you again.
0.05.
Exactement. Okay, so when you run the test, it's here alpha 0.05. Here it's giving you the significance level. Okay, significance level denoted by alpha. Ici, SPSS tells you about the confidence level. But c'est la même chose, okay? Because the significance level is 100 basically, or 1, depending on whether you consider a proportion or a percentage. So if it is percentage, it's here 100 minus 95 will give you the significance level, 5%. Therefore 0.005. One way to recall that, if ever you're getting any difficulty to just make sense of it, like using the technical term, because it might not be like super obvious, why are we using the word significance level and confidence level? I mean, confidence level does make sense, right? Intuitively, the meaning of it. Significance level might not be like super intuitive. Why do we refer to that significance level? Okay. Because the logic behind using a significance level thing is that you're looking significance, whether it's significant enough to reject H note. That's the part which is maybe a little bit, we say, counterintuitive. Okay, but you have to think about it again. Why are we saying significance level while we're looking for a low value? Because actually we expect to have a low value, because the lower the value, then the more evidence we have against H naught. Okay. So that's why both appear to be like a positive, there's a kind of positive connotation, both of the confidence level and the significance level. And that's what can get it to be confusing. So if you want to, like, if you're getting confused with it, if you're fine with it, then it's okay. But you're still a little bit confused with it, you can, if you want, just think about the confidence level, well, simply as the degree of certainty that you have, level of certainty, confidence level, level of certainty. Then your significance level, I say again, the significance level actually represents the degree of uncertainty, the level of uncertainty. So it's the opposite of confidence level. Significance level is the opposite of confidence level, okay? And represent kind of your degree of uncertainty. Okay, so we're referring to our kind of, to our alternate hypothesis, our claim, and then we think how certain we are about it, how uncertain we are about it. Okay, so that's basically what it is. Okay, so that's here confidence level c'est 95%, okay, 0.95. Mais c'est la même chose, we could have written here significance level 5%, that is 0.05, same thing. Okay, sans problème, we click on OK, we get our results, and that's what we have here. Okay, so if we compare the results here, so we have T value 4.675, significance value or p-value 0.000. All right. Our mean value, actually, our estimated mean, c'était 106.96. C'est ça qu'on compare avec 100, the hypothesized mean, reasonable assumption. And what the test tells us basically is that we have actually a significant difference. So if you look at the Excel result, do we have the same thing? We should. The T statistic 4.67, all right. As you can see, it's the same thing. Okay, there's no reason why it should be different. It should definitely be the same. Okay, p-value, significance value, say 0.000. In Excel, it gives you the exact value actually. So let's put it here. Okay, so we are looking at the two-tailed test. Okay, so that's what we want to look at. Of course, you could do a one-tailed test as well. But the important thing is that here, so it's 1.41, okay, E minus 0.05, okay. And so basically it's, so you have therefore 4 zeros to add there, okay, basically. So if we have it here, the exact figure, which you can see here, c'est 0.00004. So 3 decimal places, ça fait combien? 3 decimal places, of course, what would be Z? That would be 0. Okay, so SPSS gives you the exact figure. Yeah, so Excel, that's it. In SPSS, you have 3 decimal places, and you have 0.000. But it's nice to see the exact figure here and to realize that it's never going to be actually 0, because sometimes when you look at the output from SPSS, you might tend to think, well, it is 0. No, it cannot be 0 actually. 3 decimal places is 0, as you can see here. Okay, so that's good. Now let us interpret the results. Okay, so let's interpret the results. So I want you to try and do it first by yourself, and then we look at it together. Okay, so I'll give you 2 minutes. So try to interpret the results here. Okay, tell me whether the result is statistically significant, yes or not. What do we do? Do you reject H naught, or you don't reject H naught? And what's your conclusion, basically? Okay. Okay, give you 2 minutes for that. Okay, c'est bon. Allez, right. So, what's your conclusion? Hmm? Yeah, tell me what's your conclusion here? Is there a significant difference between our estimated mean value and the hypothesized mean value, a reasonable assumption of 100? Is the difference statistically significant? That is it a difference which is likely to be true, not something which you obtain due to sampling error? And if yes, so what about the difference? Does it appear that students are more intelligent compared to world average? So on average, students have a higher IQ or lower? I mean, first of all, is the difference statistically significant, or is it not different? Can we just conclude that there is no difference? What does the test tell us? Yeah, I'm waiting for you. Yep. Well, let me know if you're still here to start with. Okay, let us ask questions and make sure you do reply, otherwise it becomes difficult. Well, Alvin, Amsami, are you here? Alvin? Zayed, can you hear me? You want to start?
Oui, monsieur.
Busy là. Ça, online, c'est une fois ça. Allez, oui. Et ouais, Alvin qui n'avait pas pu répondre. Dis Alvin, c'était un numéro d'action, écoute, pas possible ça. Au moins, il a répondu dans le chat s'il y a un problème micro, ça va être.
D'accord, monsieur, mais p-value là, il less than significance level. Mais nous faisons
Tu peux répondre du toi. Non, attends, nous avons Alvin, là, que Alvin était. Tu te s'appeler. Non, tu camarade Alvin qui va pas répondre. Première affaire.
Attends, me contacter.
Allez, right. Bon, entre-temps, nous était. Parce que une tutorial session, ça vous que si vous participer aussi, etc. Sinon, vous n'avez pas. Si vous pas PC, je demande pas si réponse n'est pas un problème, dit-il. Mais laisse-moi connaître. Et yes, Neha Radikanat.
Yes.
Yes. Okay. Good. So tell me, what would you conclude here? Is the difference statistically significant? Allô? On est disparaître.
Je sais pas.
Ok. Et non, pas de problème. Allez, arrête. Et Jonita?
No, I don't know.
Ok. Et, ok. Just Yogesh.
Monsieur, bonjour. Sorry, me tu fais pas me manger. Me parti dans me la chambre.
Sorry, qui s'en fait causer là?
Alvin.
Ouais, qu'est-ce que tu veux faire?
Ah, me tu fais pas me manger.
Pour manger, c'est là, désir.
Ouais.
Mais tu peux toi, suis dans le tutoriel là, avec comprendre on est qui peut arriver.
Ici, me tu pêché, me tu n'es qu'à aller like 5 minutes.
Ça, mais c'est ça qui me dit, j'ai foutu. Arrête, mais ouais. Mais tu vas trouver une peu faire une affaire importante, hein?
Yeah.
Ouais.
Sorry,
Bon.
monsieur.
Ouais, ouais. Allez, bon, question. Bon, moi, je ne connais que ça. Bon, écoute ça. Question là, simple. Là. C'est à quoi ça tu peux suivre, tu peux suivre, etc. Là. Tu connais question là au moins qui était, non?
Euh, non.
J'ai besoin de comprendre ça fait. J'ai tout là, pas d'histoire, Vin. Ça, tutoriel session, on a dit, pour c'est pas pour moi. C'est comme expliquer mon pensée, pour moi, je peux réaliser, je peux faire tutoriel session pour je. C'est si je ne sais pas pêcher, mais un petit problème, pas trop rien comprendre en fait. Et en fait, moi, même supposé dire, c'était une assez compliqué, la vie assez compliquée si je peux faire pour moi. Parce que, vous connaissez, on n'a pas évident, mais qu'est-ce que ça? Il y a une situation que peut bien faire classe online. Right? Et comment il n'est pas évident pour ben lecture, c'est bon professeur. Right? Il n'est pas évident du tout, du tout. Si je me suis capable de faire ça, tu me dis, bat tutoriel, là, moi, tu sais, caca, c'est une pause, tu vois? Vous pensez à tes réaliser qui me paye. Pas connaître si je peux trouver, mais artistes me connaît, me paye. Travail bien, je fais artiste pour faire ça, c'est intéressant, moi, comment capable, et faire lias. Anyway, with the means we have online notes, qui OK, au fait, moi, PC faire as useful as possible, vous êtes, mais il peut venir un problème si c'est pas passif. Ouais, ne pas trop connaître qui vous fait, moi. Bon. Allez, right. Et... Bon, Amine, moi, on sait qu'on est là. Si tu as envie, tu es capable d'aller, tu vois. Au fait, moi, tu préfères te aller, au fait.
Non, non,
Ouais. Qui fait te manger? Midi, qui fait te manger? Qui fait te manger ça, là?
sorry, monsieur.
Non, ça y est. C'est dans le chat avant.
Ouais.
Ouais. Bon, il fait manière de suivre tout là parce que, en fait, une affaire, j'ai besoin de dire, moi, écoute ça. Fait commencer si j'ai une fatigue, j'ai besoin de break aussi. Je dis, moi, j'ai besoin de ça. J'ai besoin de break, c'est pas une faire une en classe, j'ai une saturée, je prends un break. Si moi, bon, j'ai une affaire, me venir. Après, je réconcentrer. Mais, il faut bien comme ça, sinon, il est bête. Ouais, parce que, on va dire, si on peut causer ça, péché, il est difficile pour ça net là. Surtout pour un tutoriel. Lecture à la rigueur, comment dire, j'ai une gratte, une bout, je pourrais lire, je pourrais etc. Le tutoriel là, c'est juste là, je peux pratiquer, je peux étudier pour comprendre. Mais comme j'ai besoin de faire des efforts pour comprendre tout de même. Right. Tu fais sport, Alvin?
Oui.
Qu'est-ce que tu fais? Football, le gym,
Non, mais juste commence à jouer un peu.
ouais. Tu fais du football, c'est
Ouais.
ouais. Tu sais comment il était là? Comment tu te fais l'entraînement football?
Ouais.
Right. Il y a une session d'entraînement. Lecture, il commence à te faire des vidéos, tu vas te faire des matchs là. Tu comprends là? Mais tutoriel là, il commence à te faire l'entraînement, tu peux pratiquer là. Ensuite, tu peux casser une pause, tu manges bon, tu peux guetter tes yeux. Il y a un peu comme moi là. Tu comprends qui on peut en côté? Comment est-ce que tu peux réaliser?
Ouais, je vais comprendre, monsieur.
Allez, right. Allez, bon, écoute, ça va peut-être avec toi là, Alvin, mais bon, si on peut faire une petite leçon plus de dessus là en même temps, parce qu'il me commencer peut-être par tout seul, comment dire qu'il ne peut pas trop suivre là. D'accord, ça. Si, bon, comme moi, si tu as envie, je te bien dire aussi, hein, mais envie, j'ai de mon feedback. Si tu as envie, comment dire, peut-être moi, connais-moi, on fait session 15 minutes, je prends un petit break, 15 minutes, ça fait comme moi, peut-être, les cas focus, sinon, il est compliqué. Nous faisons les comme moi. Mais dis-moi ce que tu as envie de aussi, mais pas comment dire, je sais pas qu'à sa tête après, comment dire, des problèmes. Bon, allez, ouais. Anyway, so let us look at this again. So, qui s'en a volonté là? Anyone wants to give it a try?
Je suis pas sûr seulement, mais
Enfin, non, c'est tout.
significance p-value là, il less than significance level.
Yep.
Alors, nous pouvons reject H node.
Yep, exact. Yep. Okay, so in a sense, that's what you do. Okay, so you have your p-value here. Okay, so you're considering the two-tailed test. Forget about this. Actually, you want to delete it, you delete it. So this value here is much less than 5%. Okay, that's the exact value, as you see. So we'll reject H node, right? We reject H node, and what do we conclude? That we have enough evidence to reject the null hypothesis. There's no reason, therefore, to believe that there's no difference, that the average IQ of young students will be equal to 100. Our estimated mean value was 106. We find a difference, and this difference is actually statistically significant. Okay, now when you need to interpret, I think I showed you last time for independent self-validity tests, you need to write it well, okay, when you report it in your dissertation, in a new research project, you want to write it in a neat way. So for example, here you will see that something like that. So the average IQ of students, okay, and if you want here, you can actually write the exact statistics. So you have a mean value of 106.96. Okay. If you want, you can write the standard deviation as well. Otherwise, just write that. So was hypothesized to be different from the world average IQ score IQ of 100. Observed difference. So you observe a difference. And what's the difference? The difference between 100 and so 106.96. So it's 6.96. You can say it if you want. Okay. Was found to be statistically significant. That's what you find. Okay. If you want, you can specify at the 5% level of significance. And here you can report the t-value and all the statistics. So the t-value, normally you write the degrees of freedom, so it's 69. So that's how you report it officially. So the t-value is equal to 1.99. Okay, so that's what it is. Well, that's that's a critical. So the t-value is 4.67, right? That's what you have here. Let me just oh là là. Okay, sorting issue. Anyway, alors t-value 4.67. Okay, and you can write your p-value. What's the p-value? So p-value, that's the exact p-value, but you can just write it 0.000, 3 decimal places. Okay. That's what it is. Okay. So you can, in addition, write a statement with regards to that. So you can say that on average, students have a higher IQ value than compared to the world average. Okay, so basically that's what you find. C'est bon? Good. So we write something like that. So that's our interpretation, and we're good. Well, okay, let me take questions. I think you might be having questions because I don't know. So you're not sure about it. So yeah, tell me if you have any questions with regards to that, and things not clear with regards to one sample t-test. I mean, please don't hesitate and ask. Yeah. Easier. Is it okay?
Monsieur, the trial, c'est pour combien de temps?
SPSS.
Ouais,
A 1 month.
1 month, okay.
So 1 month maybe would be enough for you to, to work on your assignment as well. Next week I'll be giving you your assignment.
If we create another account, will we get 1 additional month?
I'm not
and
sure.
we
No,
don't-
I think it's based on your IP address or something like that. So yeah.
Okay.
I mean, I mean, there is a way to do it. I don't know if there's a friend one told me I don't know how to do that, but yeah, there's something you need to delete on your laptop. So yeah, it's not straightforward. So.
Okay.
Yeah.
Monsieur,
C'est bon? Yep. Oui.
concernant pour data analysis là, sur Excel, mais quand nous s'est dit tu testes, tu samples assuming equal variances. Un petit peu moins trop clair là.
Yeah. Et au fait, bon, ici, là, il faut one sample to test, on comprend. C'est juste une façon pour get around parce que nous payons un test là. Ça l'est OK, ça.
Oui.
OK.
Ça, okay.
Là, ici, nous mettons unequal variance parce que nous pouvons 7 demi-variables. Ça, c'est clair là.
D'accord, oui.
OK. Allez, so far, so good là. Allez, maintenant, nous pouvons get ça independent sample to test là. Et là, moi, je vous répondre à ta question. Good? Et ça y est?
Oui, monsieur.
Yeah. Ta question, c'est que quand nous servons equal variances, quand unequal variances, non?
Oui.
Okay, right. Allez, me répondre à la question. Quand on peut get independence about test, okay, that's what we do next.
D'accord,
bon?
monsieur.
Okay. Allez, so let's move to the next one. So once about test, moi, je suis OK là, hein? Pas supposé un problème avec ça. Allez. Okay, so independent samples, the test. Let's look at this one now. Okay. Okay, so we'll proceed the same way. We do the test on Excel, we do the test on SPSS. Okay, so now let's take the same data set. You don't have to do that always, and you can just do the test on another sheet, but I'm just doing that so that you can easily kind of picture it. Okay, so now let us say now we want to do an independent stability test. So we have another research question. Okay, so we have another research question, another hypothesis. Okay, now we have a research question which is like that. So is there a difference So we simply want to know if there's a difference in the average height of male and female students. Okay, is there an actual difference? And let's specify here like a population so that it's clear. We're referring to okay, just to make it simple here. So same thing. Okay, so what would be the H0 and H1? So just write it quickly. Okay. Okay, c'est bon, you written it.
Oui, monsieur.
Okay, so basically H notice there is no difference. And H1, there is a difference. Okay, si c'est un peu ça, I think that should be good. Okay, so now let's say we want to do an independent sample t-test. Okay, ici c'est différent. What do we want to do? We want to test, we want to compare two different means from two different groups, which we can consider as two different samples. Okay, so in that case here, if we want to conduct a test, okay, and find if there's a difference between those mean values, the test to use is the independent samples t-test. Why? Because it's like we're testing two mean values from two different groups. Because when you think about it, that's what we're doing. We have a male group with a female group. For each one, they have their own mean values. We want to compare that. And we want to know whether there's the difference between in height, okay, between male group and female group, is it statistically significant? Is it statistically like different or not? Is the difference statistically significant or not? Okay, so let's do the test using SPSS, sorry, Excel and SPSS, both of them. Okay, so let's do it on SPSS first this time. Okay, just to change. And so what we'll do on SPSS, we're going to analyze, we're going to compare means, independent sample t-test. If you remember in our last lecture, we did that. And let us say we'll take height 21 years old. Okay, so we'll take the height for 21 years old, because now with data set we have two variables for height. Okay, but we'll focus like on the present current height, so 21 years old. So you take that, and then you have a grouping variable here. Okay, a grouping variable will be gender. And if you recall in SPSS, so you need to specify again how you have coded each categories for gender, because we're dealing here with a categorical variable. So we need to click on define groups. And if you have a look at your data set, you can check it. We have coded one group as 0, the male group, in fact. And we have coded female as 1. Okay, so that's the values are assigned. So just see that again, click on continue. You just want to check options, and normally it's 95%, but your confidence level, I guess, a 95%, 0.95, which corresponds, I think it's clear by now, to a significance level of 5%, 0.05. Okay, continue, we click on OK, and we get our results here. And basically that's what you need to interpret. Okay, so we just keep the interpretation in abeyance. Okay, and let's do the same thing on Excel, and then we look at the interpretation of the results. Of course, we'll get the same results both on Excel and SPSS. Okay, so how do you do that on Excel? So we click on data analysis, same thing. And now we're going to select one of those two here. Now, Excel, and here comes Zaya's query, which was a very good one. So Excel actually require you to choose between the assume equal variances and assume unequal variances. And actually, you don't know what it is. In SPSS, it doesn't ask you to do that. In fact, it runs the test and then provides you for the results for both equal variances assume and equal variances not assume. It gives you the test of a Levin, it gives you the Levin's test for equality of variances. And then based on this test, you decide whether you're going to look at this line of result or this line of result. This line corresponding to equal variances assumed, and this line corresponding to equal variances not assumed. Okay. Well, I did show you last week, okay, how do you interpret that? So basically here, when we test for equality of variances, so the Leibniz test for equality of variances, we are actually testing a hypothesis. The H node being, there's no difference between the variances. And H1 being, there is a difference. So if you have your significance value, which is here greater than 5%, so you do not reject H node. So the assumption that there is no difference holds true. You don't reject the assumption. And therefore, we can conclude that equal variances can be assumed. Right? So there's no kind of significant differences between the variances. And you can therefore assume equal variances. That's what this test tells you here. So therefore, in Excel, you're going to use this one here, right? Assume equal variances. Now, your obvious question, I'm sure, will be, but yeah, we know that we should assume equal variances because we have results from SPSS here. You have the output, and then because of that, you know, okay, the Leibniz test is given to you, and then you know which one you need to use because we've done the test, and you know whether equal variances can be assumed or not assumed. Okay. But what if you don't have SPSS? Because that's the whole point of learning how to do it on Excel as well, right? So what do? So then you have actually so easily accessible like online calculators, right? So test for equality or variances, which you can easily find. So just type in online calculator or something like that. Okay, and for example, you have this one here, which is nice. Now, all those obviously can be calculated by hand, even the one sample t-test and even sample t-test. It's not that difficult if you have a small data set to calculate that by hand once you know the formula. So the Leibniz test, of course, can be calculated by hand as well, but the whole point of using a software is to make things easy and be able to learn many things, because when you have to calculate everything, then it's not easy to learn many things. And as a social scientist, what you want is to make use of statistics for your research. It's not about learning the nitty-gritty of it like a statistician would do. Okay, but of course, the more you know, the better it is. So basically here, what we need to input here, so you need to provide some specific information here. I need to check again. So basically what it looks for in this test. Okay, so basically, actually, for this test, you just input the data there. Okay, so if you have for each group, let us say, so we cancel that. So we are looking at height, isn't it? So basically, it's very easy. What you would do is just take, so 21 years old, we're looking at, right? For the first group, so that's all, which is 0 here. So we take the first group here. Okay, the male group, and you go on your, okay, you insert that, and we do the same thing for the female group. Okay, it's 1 here. Well, to have it, one of the viewer just need to filter it out, okay, or sort it by ascending order here, just to get all 0 together or 1 together. Okay, so I think this was already done here, but if you have a data set and it's like mixed, you just need to sort it out, and then you have your 2 groups easily sorted out. Okay, sample 2. Okay, so that's for the female group, right? Okay, so sample 1, sample 2, and then we just say calculate, and you should normally get your results here. And here we are. Okay, so here are the results of a Leibniz test for equality of variances. And it gives you the result here. So the F ratio value is 2.32. The P value is 0.132. Okay, normally that would be exactly what you have in SPSS. So just remember that. F value 2.32 et p-value 0.132. All right, so if we go here on our SPSS, okay, F 2.32 and p-value 0.132, right? And that's what you get. Yep. So if you're not using SPSS at all, okay, you want to do it on Excel, for this part here, where you need to choose between the whether you can assume equality of variances or not, you just make use of an inline calculator like that. Okay, super easy. Let me just share that with you on the chat box here. Right. Okay, so that's a Levene's test. When you're using Excel, you do that first to test for equality of variances, and then you will choose. C'est bon, Zahir?
Oui, monsieur, c'est bon.
Okay, good. Okay, so now we're ready, okay, to proceed in Excel. Okay, so even if we had not done it in SPSS, okay, so looking at the Levene's test here, we know that the p-value is 0.132 for the Levene's test, so we can assume equal variances. So therefore, when we're going to do the test here, we come here and sorry. Okay, so let's suppose who are doing it at the same time, and so please, so just let's do that together. So data analysis, and here we click on two sample assuming equal variances. Why assuming equal variances? Because we've done a Levene's test and we know that there's no significant difference between the variances. We can assume equality of variances. Okay, so we click on that, and you click on OK. And so again, now we are required to change to choose a range. Now here we need to be careful about it. So we need to choose two range of data. All right. So one for the male group and the second one for the female group. So male group is whatever is 0 here gender. Okay. So if you want to be sure not to do any mistake, you can actually filter as well. Okay. So I mean, you could actually just use a filter option, cancel it, but here I think we can easily figure out. Okay, so just select all the data which pertains to the male group here, yeah, and we stop here. Okay, so just make sure you don't do any mistakes. So that's student 36. Okay, still male with a 0 here. So you select that, and we're good. The second variable range is a female group. So it starts from student 37, as you can see. All right. So yeah, we select this data. Okay, we're looking at the height 21 years old. So you select that up to here. Okay, c'est bon. Variable 1 range, variable 2 range. And now we're good. Hypothesize mean difference. Now, what's important here? Earlier, you remember when you did one sample t-test, we selected 100 because we had a dummy variable, etc. Here, we'll actually insert, who can tell me actually, what is a hypothesized mean difference here? What is a hypothesized mean difference? Basically, we're referring to H naught here, in fact. What's the value against which we're testing? What does H naught tell us? According to H naught, is there a difference between male and female group or no difference?
No difference.
No difference. Therefore, basically, our hypothesized mean difference is 0. Okay, so whenever we're doing a test where we're comparing two groups, okay, whether a independent sample t-test or a paired sample t-test or whatever, the hypothesized mean difference is actually 0, because that's basically what we are showing, 0. Okay. So good, alpha 0.05, And then output range, if you want the output to appear here itself. So you just select this here, select some place here. Okay, otherwise you can have next worksheet and it creates another worksheet for you. Okay, but we want it to be here, so we select that. And we click on OK. What's happening now? To test input range, something which has not been selected somewhere. Okay, let's select that again. For some reason that changed. Let's click on something. Okay. The only thing is on Excel, as soon as you don't select something well, okay, so that's what's selected. Now I think it's good. Okay, there you can actually verify it or it's good or not. Okay, so now it's good. Okay, so we click on OK and you get your results. Now that's the results of the independent samples t-test. It tells you to test two sample assuming covariances, of course. So variable one, so those are the two groups. So as you know, we have chosen male group first. So we have male here, and then we have female here. Okay. So that's the results of independent sample t-test, and here are the results. As we said, we're always going for a two-tail test, so just delete the one tail. We're not even going to look at it. Okay. So here are the results. Okay, and normally you should get the same result in SPSS. So if you look at the t-statistics 9.53 or 9.54, right, your p-value basically is 0.000. Okay, it's e minus 14 here. Okay, so yeah, so you have 13 zeros to add basically. So yeah, so very small. But so if we look at our SPSS results, okay, of course we take equal variance as assumed. The t-value is 9.537. Okay, and that's exactly what we find here, 9.53. That one's going to be 7 if you just have it to 3 decimal places. Okay, 9.537, same thing. Okay, so we've done it the same test, okay, on SPSS Excel. I hope you've been able to do it at the same time. Again, if you have any issues with it, don't hesitate to let me know anything you've missed. Okay. Okay, so now let's interpret the results. Okay, so basically what will you conclude? What do you do? Do you reject H-note or don't you reject H-note? And let me look for this somewhere that I had already done the work example of that, so we don't lose time. Okay, so basically that's the interpretation of it. Okay, let me just copy that instead of writing that again. But we have time to finish. Okay, because I want to complete that. Okay, so I don't hear much from you. I just hope you're not lost with it too much. And well, in any case, I'll be giving you some homework to do and you have time to practice. So basically here, so P less than 0.05, you reject H-note, that's what it is. But then you need to report it in a nice scientific manner. Okay, and that's basically what you can write in terms of interpretation. Okay, so you find that there's a significant difference between the male and female group. If you look at the mean values, you see that here, okay, there's a large difference, okay, between the average height of female students in our sample here. So we have 36 male, 34 female in our sample. And based on sample data, we get actually, so for the male group, 172-ish, and female group 155-ish. So it's like quite a huge difference, a big difference, 16 centimeters difference between the two. Of course, since we are running a sample, same holds history. So we need to do an inferential statistical test. That's why we do an independent samples t-test, just to make sure that whatever we observe in terms of difference here is not something which is likely due to sampling error. It's something which is likely to be true. So we have our hypotheses and we see whether we have enough evidence against the null hypothesis. The null hypothesis telling us that there's no difference. And what we can see here, based on the sample data we have, based on the results we have here, we have enough evidence to reject the null hypothesis. Why do we say that? Because we have a p-value here, which is less than 0.05, less than 5%. So the probability of finding such a difference, while actually there was no difference, this probability is very low. Okay. I hope that's starting to kind of become I mean, you're getting used to it, basically. Yeah. So again, criminal case, you know, what's the probability of getting so much evidence against the H0.1? Okay, so that's what we're saying again. Okay, so we'll always do that actually for any test we do, so better get used to it. Okay, but if you still have difficulties with it, please go through the examples again, read it, try to work it on your own. And if you still have difficulties, don't hesitate and ask, please. Okay, that's good then. So I will do a last one, okay, paired sample t-test, and then we're good. And then, well, we'll continue with other tests in our lecture on Thursday, right? But I want to do a last one, paired sample t-test. I don't think I did it in lecture on last Thursday as well, but it's quite straightforward and you shouldn't have any difficulty. Well, if you understood the two previous tests. Okay, now using the same data set, let's say we have another research question now, but this one is different and we require therefore another test. So let me just copy that, so make it easy. Okay. So let's say we have another research question now, which is totally different. We want to know, if you don't mind for this one, I actually already have a work example for all of those, but I mean, I prefer to do it at the same time with you. So I think it helps. It helps in your understanding, provided you're following, of course, and not going to prepare food. So that's why I'm taking time to work it with you at the same time, but it's up to you to make the most out of it. Well, anyway, for the paired sample t-test, if you don't mind, I'll just jump to the worked example so that we can go fast with it. So in Excel, it's not difficult to do that. So you just have to go on data analysis, and here you select paired two sample for means. Now, when do we use a paired sample t-test instead of an independent sample t-test? You see, for the independent sample t-test, we are comparing two mean values, but coming from different groups. The male group, for example, in our example here, and the female group. Those are two separate groups, which are not related to each other, obviously. What if you want to compare two mean values, but those two are related? For example, here, if we want to compare height for 15 years old and height for 21 years old. But then when you look at it, well, we are actually looking at the same students. Okay, so for student one, when he or she was, so it's he here, the male, so was 660 when he was 15 years old. Although his height was 162 centimeters, and now that he is 21 years old, his height is 168 centimeters. Student number two was 148 when 15, and now is 150 when 21. Okay, we take another one at random. Let's take for a female student now, but same thing. This particular student here, 160 when 15 years old, and 61 now when 21 years old. Okay, for some they have increased by a lot. For some, just a little bit. Some have stayed more or less the same. Okay, that's normally what happens. So, and now we want to see if there's a difference between average height when students were 15 years old compared to their height, the average height when they are 21 years old. We expect that there's a difference, obviously. But is it really a large effect, and is it statistically significant? That's what we want to test. So because here, each observation relates to the same student, as you can see. So it's not really two separate groups. It's not two independent groups. It's two dependent groups. That's the way we think about it. So therefore, here we conduct a paired sample t-test instead. Okay. So to do that, we go on data analysis. Okay. And paired two samples for mean. Click on OK. And of course, here you select the range. And so for the first range, you select the whole, for 15 years old, the whole data here. And for the 21, you select the whole range here. Okay, so just select that here. And then the hypothesized mean difference again will be 0, always going to be 0, unless of course you're doing a one sample t-test, which is different, where you have a reasonable assumption. But once when you look at the test for difference between two means here, it's going to be 0 because that's what your H note is. Your H note is there's no difference. Of course, alpha 0.05, and then I'll put you just like it on here, and then that's what basically you will get. Okay, same like we did previously, and when you interpret the results. I will just show you how to do the same thing on SPSS, analyze, compare means, paired samples t-test. Here it's a bit different, okay, compared to what we had when we do an independent sample t-test. So it tells you variable 1, variable 2. So we have height, we send it there, height, we send it here again. I mean, for variable 2, options, 95, we're good. It's like, okay, and we get the results, which is going to be the same anyway. Okay. Okay, so I know I went a bit fast for these two. What I will do, I will send you the work examples. I will send you the video of recording of what we did today as well. But then what I do expect you to do is to work out the examples and by yourself. Okay. So I will send you the worked out example. Okay, so everything which has been worked out with interpretation and everything, but do it by yourself. Okay, with the same data set here, do it by yourself again. So that would be the first exercise. Then what I will also want you to do, there's another data set which you have downloaded already. It's named academic performance. And I want you to do the same thing for academic performance. Okay, and so, well, don't do it now. Okay, on Thursday I will explain to you the second exercise. Okay, what you need to do for those three tests: one sample t-test, independent samples t-test, and paired samples t-test. But for now, for today, once you've been able to install the SPSS, work out the same thing. Okay, using the same data set here. Test for querying means data set. Do the test on Excel again, do it on SPSS. Okay. And so whenever you're not sure, look at the work examples. And yeah, try to do it again by yourself. And then note down your questions. I hope. I mean, there's only two possibilities, right? You understood everything, and so therefore you have no questions. Or you're working on it. I mean, there are three possibilities, isn't it? You understood everything, so no questions, or you work on it seriously and therefore you have some questions also, so because you're not understood everything yet. Or third possibility, of course, is that you have not understood anything and you're not working on it as well, which I hope is not the case for any of you. So try to do it by yourself, and I will take questions on what you may have on it on Thursday. Okay, let's do it like that. C'est bon. Unless you have specific questions now, I'm happy to answer as well. Yep. Anyone?
Monsieur, on connaît quelle réponse pour le. Est-ce qu'il nous supposé que les pareil comment on fait pour sample t-test pour paired samples ça?
Oui.
Par
Bon,
exemple, littérature à la fin.
Excusez-moi.
C'est-à-dire réponse à la fin quand vous écrire le littérature. Et si nous faisons écrire un peu similaire, comment on fait pour le
Oui. Alors, tout le temps, je peux écrire. Alors, c'est que, so, je peux envie commenter la différence, actually, je pense descriptive statistics, alors quelle est la différence actuelle between the two means, and then you report the t-statistic, the p-value, you say whether you're going to reject the H-note or not. If you reject the H-note, basically, what does it mean? So difference between which variables. And then, yeah, you make sense of it. So par exemple, dans ce cas-là, ici, il y avait la différence entre ce height of 15 years old and 21 years old. So have increased. So basically, you expect it to have increased. So you say that. Yeah. So you need to interpret it same way at the end. Yeah.
D'accord, monsieur, merci.
Okay. You will see in the work example that I'll be sending you, I've already included the interpretation as well. And you will also find the PowerPoint as another example there. But again, the point is that you should try it by yourself. Okay, so try it by yourself first without looking at the work solution. And then if you're not sure, you look at it and then you do it again. But and then on Thursday, I will be giving you another exercise to work on it. And yeah, I mean, the best way to learn about it is to practice, and then yeah, so practice, and you should be fine. C'est bon? But do work seriously on that, right? Because as we proceed, you will be learning new tests, okay, new statistical analysis, and if whatever we've done is not clear, then it will have a spillover effect, okay, in both ways. Okay, if it's already clear, you're able to learn. So as soon as we look at a new test, you learn it and it's clear in your mind, then the next test that you learn is going to become easier because you already kind of understand the underlying principles, okay, beyond the interpretation of the test and how to do the test, etc. So it gets easier and easier. But if it's already getting difficult, more and more difficult, then it's going to continue and become more difficult. So you need to know what's happening to you. Okay, is it becoming more and more easy for you? Then it's a good sign. If it appears that it's getting more and more difficult, then you know that you have to take action right now. Okay, and you should let me know as well so that I can help you with that. Good. But the thing is, you need to practice. C'est bon tout le monde?
D'accord, monsieur, merci.
Yeah, c'est bon, ça y est. Okay, good. Yeah, well, et sinon, bon, as you know, l'école, stuff. Let me stop recording.